Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is determinant of a matrix. The determinant of a matrix is just a number that is specially defined only for square matrices. Determinants are mathematical objects that are very useful in the analysis and solution of the system of linear equations. The application of determinants is very wide. Determinants have wide application in engineering, science, economics and social science as well. Okay, let's now study about the determinant of a matrix. To every square matrix A, which is equal to Aij of order n, we can now associate a number. A number could be real or a complex. It's called a determinant of a square matrix A, where A equal to ijth element of A. This may be thought of as a function which associates each square matrix with a unique number. The number can again be real or complex. For example, if M is a set of square matrices and K is the set of numbers and FB, M defined to K, and it is defined by F of A, which is equal to K, where A belongs to M and K belongs to K, then F of A is called the determinant of A. It is also denoted by, I'll write it. It is either denoted as determinant of A or in the words det A or in the symbolic representation. Okay. If A is equal to ABCD, then the determinant of this matrix is written as, hope you understand the difference between the matrix and determinant. Okay, now let's learn the properties of determinants for 1 by 1, 2 by 2, 3 by 3 and for the greater one. For a 1 by 1 matrix, let A equal to A, which is of the matrix of order 1. Then the determinant of this matrix A would be equal to just A. Does this make sense to you? So for 1 by 1 matrix, the row is equal to 1 and column is equal to 1. It means there will be just only one element in the matrix. If you find the determinant of that matrix, it will be equal to the element itself. So this is the condition for 1 by 1 matrix. Now let's see what will happen for 2 by 2 matrix. For 2 by 2 matrix, so what is mean by 2 by 2? 2 rows and 2 columns. Let me take an example. Now let's find the determinant of this matrix A. So determinant of A would be equal to A times D minus of C times B. So whenever you multiply a variable, you should maintain the order. The order should be in the alphabetical order. A, D, C, B. Or the determinant of A is equal to A times D minus B times C. It is easy to remember when you think of a cross, where you can mark a cross here. I'll take an example and explain you. You can assume any number. It may be a positive or a negative. So let's find the determinant for this matrix. We know that we have to cross multiply and place a minus sign in between. So therefore, determinant of A would be 2 times 8 minus 3 times 4. So you have to perform the operation and subtract them. So it would be 16 and 12. 16 minus 12 is 4. It is not necessary that your answer should be always positive. So it depends upon the elements that you get. So depending upon the signs, the sign for the answer will differ. It is not like the area of a triangle. For area of a triangle, all the answers should be positive. So you have to take the absolute value there. But here, it is not necessary like that. You have to just work out according to the formula. So for 1 by 1 matrix, you'll get the element itself as a determinant. For 2 by 2 matrix, you have to cross multiply and place a negative sign in between. Now let's see for 3 by 3 matrix. What is mean by 3 by 3 matrix? Yes. In a matrix, if the row is equal to 3 and the column is equal to 3, then it will be called as 3 by 3 matrix. Let me take an example. This is how a 3 by 3 matrix will look like. Now let's see how to find the determinant of this one. You have to keep the first element as it is and ignore all the elements in the corresponding row and column. And consider this. You have to apply the same 2 by 2 matrix determinant formula. You have to cross multiply and place a negative sign in between. And here you have to keep the alternate signs, you have to change the signs alternately. First you have to start it with a positive one and negative and positive. So it will be keep on changing. if in case if you are getting more number of MIN matrix. Okay, let's apply this formula here. So I'll be getting, if I consider A, I should ignore all these and cross multiply these two and place a negative sign in between. So I'll get A times EI minus FH. Am I right? Same way, I should place a negative sign of this. So B times, cross multiply these two, ignore this row and column. So it would be DI and FG. If for C, I should ignore this row and column. So if I cross multiply, I'll get DH minus EG. So this is how we find the determinant of a 3 by 3 matrix. So determinant of A equals A times XI minus, E times I minus F times H minus B times DI minus FG plus C times DH minus EG. So it may look complicated, but if you observe this pattern, it will be really easy. So you can note down this format. So to work out the determinant of a matrix 3 by 3, first multiply A by the determinant of 2 by 2 matrix, that is not in the A's row or column. Likewise for B and C, sum them up, but remember the minus sign in front of the B. So as a formula, remember the vertical bars, which mean the determinant. So whenever you're denoting any determinant, you can use this one, det of A, or the bar between this, and or you can mention a delta sign. So all the three will denote the determinant only. So this is what we are doing. You can notice down this. So all these denote the same thing, the determinant of A. Let me take one example with numbers in the place of ABCD for 3 by 3 and work out in the same way. If A equal to this matrix, determine or find the determinant of A. Okay, now let's apply the formula. So according to the formula, we have to work out in this way only. Now let me plug in the values in the place of ABCD. So replace A by 6. So it would be 6 times. Hope you're clear with this step. Now work out the product according to the rule of sign. So 6 times negative 54, negative 1 times, if I do this calculation, I'll get 18, and for this one 36. So totally, if I simplify after multiplying, I'll get negative 306. Hope you're clear with this example. All you need to do is consider the first one, ignore the column and row, and do the 2 by 2 matrix multiplication. The same concept for each of the element in the first row. This is how we find the determinant. In case if you get any query, you can let me know. Now let's see for 4 by 4 matrix and higher level matrix. For 4 by 4 matrix, the same pattern which we used for 3 by 3 matrix continues. The pattern continues for the determinant of matrix 4 by 4. Okay, here it will look like, so this is nothing but plus, the sign here is A times the determinant of the matrix that is not in the A's row and A's column, minus B times the determinant of the matrix that is not in the B's row and B's column. You just have to ignore the values in that particular row and column and then do the 3 by 3 matrix for this one. Same way, plus C times the determinant of the matrix that is not in the C's row and column, and minus sign. Did you notice that the signs are changing alternately? Okay, so if we do so, you'll get this one as a formula. So as a formula, it will look like this. Here again you have to apply the 3 by 3 matrix and determinant form, finding that. So you have to apply the same concept that we discussed for 3 by 3 matrix for this portion. So it will be keep on increasing if the matrices becomes higher level, and you should notice the alternate sign changing pattern here. Here is an example. If f of x is equal to this determinant, then find f of lambda x minus f of x. There are 4 options given. Okay, let us solve and find which option is suitable. So we are given with a determinant, and this is a 2 by 2. So we know that how to find the determinant of f of x. We just cross multiply and place a negative sign in between. Am I right? So f of x would be, so by cross multiplication I'll get x square minus 2 lambda square. In this question we are supposed to find f of lambda x minus f of x. So using this, we can easily find the f of lambda x. F of x is equal to x square minus 2 lambda square. So in the place of x, we have to use the x lambda. I have just replaced all the x by lambda x. Now I am going to work out the exponent. Squaring means it would be x square lambda square. This question is asking us to find f of lambda x minus f of x. So we can plug in these expressions. F of lambda x is x square lambda square minus 2 lambda square. Same way, please make sure that you place the negative sign in between. So I'll get x square minus 2 lambda square. Now you have to distribute this negative sign with each and every term in the second parenthesis and combine the like terms. So by combining the like terms, I get these two terms gets cancelled out. Taking the common term out. So for these two terms, x square is the common term. So I'm taking the common terms outside and writing the leftovers within a parenthesis. Therefore, my answer matches with option D. So option D is the correct one. Hope you're clear with this expression? Okay. So it depends upon the example question that you're getting. You may also be asked to prove the left side equal to right side and verification, evaluation. So you may get problems of these types. So this is all about finding the determinant of a matrix. In case if you get any query, you can let me know. See you in the next